So, good morning, dear children. Let us continue with our chapter on heat, the second video, which we are going to study now on good and bad conductors of heat. Place a steel spoon, a copper strip or rod, a divider from your compass box, a pencil, and a plastic ruler in a glass beaker. Pour hot water heated up to 60 to 70 degrees into the beaker. Wait for a while. Then touch the outer end of each of the objects and record your observations in the table below. So this is the way we are going to prepare the table which is given here. Object, so name of the object you will be writing here, and how hot is the outer end. So you will describe it as very hot, hot, warm, as cool as the atmosphere. So you will try to do this experiment if possible at home, okay, and you will write your inferences here. Now what inference will you draw from this? Some substances are good conductors of heat, while some are bad conductors of heat. Heat is easily conducted through copper strip or pot, but not through plastic or wood. So hence you can see at home your mother uses copper based vessels for cooking because they are good conductors of heat. Now, we can hold a glass tumbler or a china cup full of hot tea easily in our hand, but not so a steel or a copper cup if the same tea is poured in them. So got it? It's due to the substances which are good conductors and bad conductors. Now, use your brain power. Question: why do we use white clothes in summer and dark or black clothes in winter? So, you very well know that white color does not absorb heat. It allows the body to remain cool, that is, it reflects light. Hence, we wear white clothes or light clothes in summer and dark clothes or black clothes in winter because they absorb heat, so which helps in keeping our body warm. So I hope you have understood the concept of good and bad conductors. Now let us continue with expansion and contraction of a solid substance due to heat. Apparatus: a metal ring, a metal ball, a burner, etc. In figure 9.6, you can see expansion and contraction of a solid substance. The same experiment we have in the laboratory. After the school reopens, I will show you this experiment again. So here what do? Take a metal ring and a metal ball of such size that the ball just passes through the ring. Heat the ball and check whether it passes through the ring. Now, let the ball cool down and check whether it passes through the ring. The above experiment tells us that metals expand on heating and contract on cooling. Solids expand due to heat and come back to the original state if heat is removed. However, the extent to which different solids expand is different. Here, even at home, when two lids of a tiffin box get entangled or caught in between or stuck in between, you can heat them and you can separate them. You can apply your knowledge here that on heating, a metal expands. Okay, so now let us go to the next page. So we have seen here how solids expand on heating. Now, use your brain power. Why is there a gap in the joints of the rails and of cement concrete bridges? You must have observed this railway line, you must have seen it. There are gaps in between. Now, we know that these rails are made of metals, and you know that metals are good conductors of heat. Therefore, they expand in summer. So, gaps are kept for expansion. And in winter, they contract. Otherwise, the bridges will crack and the tracks will become crooked and railway accidents can occur. Hence, there are gaps at the joints of the rails of the cement concrete bridges. Now, let us study expansion and contraction of liquids due to heat. Now, in figure 9.7, you can see the expansion and contraction of a liquid. This experiment also we can do it in the school when it reopens. Okay, so you can see in the arrangement a conical flask with water, a thermometer is also there, a hollow glass tube, and it is heated with the help of a Bunsen burner. Okay, now apparatus 500 ml conical flask, 2-hole rubber stopper, a glass tube, measuring ruler, thermometer, stand, wire gauze, burner, and a graph paper. Procedure: fill the conical flask completely with water. Insert the glass tube and a thermometer in the 2 holes of the stopper and fit it to the conical flask. Heat the water and with the help of a ruler record the water level in the glass tube. After every 2 degrees rise in temperature. Take about 10 readings. Observe what happens when the heating is stopped. Draw a graph to show the change in water level as the temperature rises. When a liquid is heated, the distances between its particles increases and its volume too increases. This is called as expansion of liquids. So, when its temperature falls, the liquids contract. So, this last paragraph you can mark it. Okay, so liquids expand on heating. Now, use your brain power in the pink box you can see here. Why is mercury or alcohol used in the thermometer? Now, in the thermometer, when we measure the body temperature, you know that either mercury or alcohol is used because the expansion of this coefficient of expansion of both is large. It expands, its expansion is regular and they are less hazardous. Therefore, they are used in the thermometer. Now, the pink box you can see the great scientist, that is deleted. Okay, yes. So you can cancel that. That is not there in the portion. Now let us see expansion and contraction of gases due to heat. Now we have seen a solid, we have seen a liquid. Now let us see a gas. Apparatus, a glass bottle, balloon, hot water, etc. Fix a balloon on the mouth of a glass bottle. Hold this bottle in hot water. What happens? We observe that the volume of the gas increases on heating. This is called as expansion of gas. So you can mark that line. On the other hand, on removing heat, the volume of the gas decreases. This is called contraction of a gas. If possible, under the guidance of your parents or elders, you can try to do the simple experiment at home. So we have seen here that liquids expand on heating, solids also expand and gases also expand. Okay, so now let us watch a video based on expansion and contraction of these substances.
Have you ever rubbed metal continuously with its surface? If so, you would have noticed that metal gradually changes its shape. It expands, therefore, there is change in either its area, volume, or shape. Even when iron is exposed to heat, it expands. These are all the effects of thermal expansion. So, what is thermal expansion? It is a process in which a body expands in either area, volume, or shape when heated. Thermal expansion occurs in solids, liquids, and gases. First, let's consider solids. When a solid is heated, it expands in size and shape, resulting in an increase in length, area, or volume of the solid. This is known as a thermal expansion of solids. But what makes a solid expand? When a solid is heated, the molecules that make up the solid begin to vibrate. This takes up more space and the solid matter expands. Let's see an example of expansion in solids. When you can't open a tight jar, it is recommended that you place it under hot water for a minute. The metal lid will expand because it heats up and won't be so tight anymore. Now, you can open it easily. Next, let's study thermal expansion in liquids. Like solids, liquids also expand when heated. However, since liquid particles are usually less tightly bound to other particles, they generally move further than solid particles when heated. Hence, liquid expands more than solid when exposed to the same temperature. In a thermometer, mercury is an example of expansion in liquids. When we increase the temperature, the mercury starts to expand, and we can clearly see an increase in the level of mercury. Finally, let us see how gases react when they are heated. Gases expand most when heated. This is because gas particles are far apart and are weakly attracted to each other. It is much easier for them to move further than solids or liquid particles when heated. Heat causes the atoms of the gas to vibrate and take up more space. For example, the gas gauge on a car. People are much more likely to run out of gas in the summer than in the winter. Why is that? Well, the gas in your car expands just like everything else, and it changes the reading on your fuel gauge. In the summer, gas takes up more space in the tank. So, when the fuel gauge reads empty, it indicates that there is significantly less fuel left in the tank than it would be during winter. You may get an extra 35 miles after the fuel gauge shows empty in the winter, but that won't be the case in the summer heat. So, be careful. You don't have to walk 3 miles to the gas station just because you don't know about thermal expansion. Let's summarize what we learned today. Solids, liquids, and gases expand when heated. Thermal expansion causes an object to expand when heated. Gases expand most when heated.
Okay, so I hope you have understood the concept of expansion and contractions in solid, liquid, and gases. Now, let us understand what do you mean by a thermos flask. You might have seen a thermos flask used for keeping tea, coffee, milk, etc. hot or a sherbet cold for a long time. What is its structure and how does it function? This is a double-walled flask. It consists of two glass tubes, one inside the other, with the gap between them sealed. The surfaces of both the tubes are made shiny by a silver coating. The air between the two tubes is removed to create a vacuum. There is a protective jar of metal or plastic outside the tubes. For the protection of the flask, pieces of sponge or rubber are fixed between the outer jar and the flask. Now let us go to the next page and understand more about the functions of the thermos flask. Now, the functions of the thermos flask. When a hot substance is placed in a thermos flask, the heat going out gets reflected due to the shining surface of the inner tube. Hence, it is not radiated. Neither conduction nor convection of heat occurs because of the vacuum. As a result, heat is not transferred to the outer cooler region and is retained inside for a long time. Still, a little heat is lost from around the lid and by a small amount of conduction through the glass. Therefore, the hot substances does not remain as hot after 2 or 3 hours. So you all must have got a thermos flask at home. You can observe the inner and the outer surfaces, and maybe you are using it at home. So you can see in the figure 9.8 the construction of the thermos flask. Observe it, the double walled glass jars, okay, and the inner silver surface of the glass. There's a spring, a metal plastic jar, vacuum in between the two layers, and a rubber support. So you can store hot or cold liquids in it. Okay. Now let us find out what is meant by thermoware. Some of you must be bringing or must have got a thermoware tiffin at home. So what do you mean by thermoware? In thermoware, these are the objects that do not allow the heat to escape from them. So the things stay warm in them for a long time. Example, the hot pot and a thermos flask. So your food remains for a long time hot. Now let us observe a video.
Vacuum flask or thermos flask. Thermos flask is used to keep things warm and cold. It consists of a double-walled glass flask having vacuum between the walls, kept inside a metallic case with cork supporters. The outer and inner surfaces of the glass flask are highly silvered. The mouth of the flask is fitted with airtight cork. The vacuum between the two walls of the flask prevent heat transfer by conduction or convection. The silver coating of the walls of the vessel reflects back heat radiations. Thus, heat by radiation can neither enter inside nor go out of the flask. The airtight cork, which is bad conductor of heat, prevents any loss of heat by conduction or convection. Some heat may be transferred by conduction through thin glass walls at the neck and the poorly conducting cork.
Okay, students. So I hope you must have followed the concept of the thermos flask, its construction and functions. Now let us move on to the exercise. So first question, fill in the blanks with the proper words from the brackets. So here the options are given, various options. So the first fill in the blank, maximum heat is absorbed by a black colored object. Okay, so you can just mark that. Second, let us go to the second fill in the blank. Second fill in the blank. Okay, so here you can see radiation of heat does not require a medium. The blank is radiation. Third one, conduction of heat takes place through a good conductor substance. Fourth, the shining surface of a thermos flask decreases the outgoing heat by reflection. So underline reflection. Fifth one, cooking utensils are made from metals due to their property of conduction. Underline conduction. Sixth, the earth receives heat from the sun by radiation. Underline radiation. You can take a screenshot of the same. I'll wait for a few seconds. Now let us move on to the second question. Here, this girl has not solved this question, but you have to write it on your own. In the textbook, you can see what will absorb heat. steel spoon, wooden board, glass vessel, iron griddle, that is tawa, glass, wooden spoon, plastic plate, soil, water, wax. So you can answer this question on your own. Okay. So let us move on to the third question. Write answers to the following questions. So the first question is, how does a fever get lowered by putting a cold compress on the forehead of a patient? You must have observed this or experienced whenever you get fever, your mother takes a handkerchief or a cloth, dips it in cold in water in which salt is put in that, so the temperature lowers. So it's called as a cold compress. So mother puts it on the forehead. So how does the body temperature lower? So this answer is given here. You can take a screenshot of the same page. Then the second one is, why are houses in Rajasthan painted white? And the third question is, what are the modes of heat transfer? So the answers are given here. I'll wait for a few seconds. You can take a screenshot of the same. Yeah. Now let us move on to the fourth question. Explain which mode of heat transfer causes sea breezes and land breezes. Okay, so the answer is given there on the page. Next, why does the outer coat of the penguins of Antarctica black? Yeah, so you can take a screenshot of the same page. Then the next question, why are heaters fitted near the floor and air conditioners near the ceiling of a room? So you must have observed this if you have got ACs at home or heaters at home. Why they are placed? What is the reason for that? Okay, so the answer is given here. Next, give reasons. An ordinary glass bottle cracks when boiling water is poured into it, but a Borossil glass bottle does not. So please take a screenshot of the same page. Let's continue. The telephone wire which sag in summer becomes straight in winter. Second, give reason. So why? And third, dewdrops form on the grass in winter. Take a screenshot of the same. Yeah, and the last one. In winter, why does an iron pillar feel colder than a wooden pole? So please take a screenshot. So I hope you have all followed the lesson. You can write the question answers of the same. Thank you very much.